Hi and welcome. This time around I have a few fixtures to make, variations on ones I've made in the past for that laser welding company. One is for this guy. You hold this piece in place and have a fixture that sets this guy relative to this slope bit right here. Although apparently I can have it perpendicular to slope bit and they're completely fine with that. It saves a bit of work, and apparently the vendor does not care. They are completely on board with it, which I think is weird because I could certainly make a fixture that would hold this piece at an angle. Location on this project is interesting. The only round hole is the center one. The rest of these are oval shaped. So that's kind of interesting, and I'm going to be using two of the oval shape holes. The only important relationship is this distance to this edge, not side to side, so it's not really a problem as we've done in the past. And I have a new locating pin variation that I'm going to try this time and see how it works. And then I have this odd bit right here, and this goes in a rotary laser welder, and it holds this part in place and this part on top to be welded. This one is worn out and does not locate accurately anymore, too much slop. But this piece rotates like this, and the laser welder comes around here and welds all of this in place. So we'll be making two more of these fixtures, and the problem is that they wear out. And you would say, well, make it out of something harder than aluminum, but apparently they need the heat conductivity of the aluminum, or you end up with other problems with the fixture in a very short time, according to them, because they do something like many hundreds per day, maybe more, of these welding, and this thing slowly gets hotter and hotter all day. And if you don't have aluminum, then you end up with problems. I offered to make it out of stainless steel or even make a stainless steel sleeve that fit in there, but they weren't interested. They said aluminum works best. When they wear out, they just replace it. The geometry is kind of odd. This one's made out of square stock. I'm going to make it out of round stock. Just see how that works out. First step is to cut off some stock. This is 2.5-inch round stock. It won't fit in my 6-jaw or through the bore of my 6-jaw. Just barely misses, which is sad, but we'll just cut off some pieces, which means we'll have some wasted ends where they're held in the jaws. This saw was designed originally for up to 3/4-inch blades. I asked if it would fit a 1-inch blade, and they said, yeah, if it'll fit, and you shouldn't need too much tension for it. As you can see, the supports for it a little bit farther back than normal, but it seems to work pretty darn well. So I've been trying it out since I accidentally got a shipment of the wrong blades, and they told me just to keep them. Mark up the location of this. It's got to be a little over 7.5 inches to include jaw depth and the part itself. I ran across these pins on Amazon, long nib marker. That's what they're calling Leto. These are rip-offs of the very expensive mold and die pens that you can buy. They work pretty darn well. I don't know how quickly they're going to dry out, but you can really reach in around things, and these things are really inexpensive. I think I got 24 of them for like 16 bucks. So if you want to check these out, I'll have a link down below to help you find them on Amazon if you're looking for them. But there's the name, if that helps. So because it didn't fit in the bore, we're gonna have to face off the ends here. This is quite a bit of stick out, even for something this large diameter, so I'm taking a fairly light cut. We're gonna face both sides, and I have two of these to make, so I won't show you all the duplication in operation. Actually, rather than ever pull this out of the 6-jaw chuck, I'm gonna turn down the end and make a 1.5-inch section for this guy that I can grab when I flip it around, and I'm also going to take the outer diameter down to final dimension as well. Because there's only 15 thousandths of material to take off here just to clean up the outside, I have to get this fairly close. Let's see, I could zero this up a little better. So this is very rough extruded material. It's a couple thousandths out around here, but more importantly, what is it out here? And the first time around I faced it out here and it was about 10 thousandths. I probably could have cleaned that up, but I tapped it in, trying to get a little closer. And we're around a couple thousandths out here. I'm only taking 15,000 material off, so I need to reface this in so that it's perpendicular to this axis. Not that that's actually critical, because this is just the supporting base, but just for my own process, I need to be careful about this sort of thing. I didn't think of it when I started, and now I'm coming back and I'm gonna have to face off some material again. This outer diameter also is not a critical value, so I might have to reevaluate how much I'm going to take off. I would like a full cleanup, that way when I flip it around, I can make sure that I can get it on center again, because that's actually very important. It might not look like it because it's such a thick piece of material, 2.5 inches, but this is a lot of stick out. This is more than 2.5 times stick out. It's really close to 2.5 times stick out. So because everything is really spaghetti when you're trying to be accurate, it's good practice to do something, in this case, like use tailstock to support the item when you're going to take off a bunch of material way out here. I have to remove 1.5 inches off the diameter, so we might as well take some big bites here. So I'm going to start with my first bite at 1/4 inch. Just going to scoop some material off here. Ready to flip it over and machine the other side, but first I can cut off the excess on the bandsaw, save myself a lot of work, because there's 1 3/4 inches to remove off of the end there. So we'll do that in a second, but I got to make another one of these, so we're gonna do that first. All right, here's interesting. Now I got it supported by a tailstock. I've increased the speed, but what I want you to check out is when I bring the cutter back, does it leave a mark? Because that'll let you know if you had deflection in the part. So we've upped our speed to 1100 RPM. So you can see the finish is nice, and it's not leaving a mark on the way back, which means I'm not deflecting the part in when I'm cutting the first time, and then it bounces back. And then the return stroke, there's almost no pressure on it, so it should leave a mark if there was deflection, but it's not, which is pretty awesome. On this last pass, we're gonna try and take all of it, oops, at one time. And once I get to the end, go to my final depth, lock the cross slide, or lock the carriage rather. And come on out. Just chamfer this guy. Forgot to chamfer this on the other one. Next operation, I cut the excess off the end here. Mounted it in a 5C collet, chuck, and I'm using a 6-sided so that I don't have to swap out my 6-jaw chuck for 4-jaw, but we're going to put a 4-sided on this later to orient the two sides correctly. This fits down the bore, so I can go all the way back with it, which is nice. So we knock this guy in. We're about half a thou out here at the end. So first step, this end has to be very carefully bored, but we need a clearance hole first. So that's going to be 0.4375, and then we'll open up the outside section to 0.687. This next step, we have to go in. We want to make the diameter 0.687, and we want to go in a very precise depth, because that sets where this little rim here, how far it extends up above the sheet metal part, and that's very important. Initially that hole, my clearance hole is too small for this end to clear here. So I moved the cutter out a little bit, removed material, and it obviously removed material both sides, and just gave enough clearance so I can start to get a measurement, and then we can walk it in. It's supposed to be 0.6875. I went to 0.6876, and it's a really nice fit. And what do you know? Really nice fit. We're going to call that good. There is no wiggle whatsoever. That's really right on the money. I was going to bring it in with sanding, but I got it right on the first shot. I thought I'd try it just to see if I could do it, and I can. So it's time to move on to the second one. Repeat this process. All right, so we've got these two pieces done. That depth is very good. The fit is outstanding. One of them I had to take sandpaper just to get the part to fit. Sanded off a couple tenths, and it's a very smooth but snug fit. So next up, we take this over the milling machine, and we've got to mill the top into a square, and then we've got to get the sides appropriately as well for the clips to pull down on the battery plate. So heading over the mill next. To get this guy all lined up, because I need the sides to be perpendicular. They don't have to be perfectly perpendicular, actually. None of that is a super precision measurement, but I've on the end shaft here, I've attached a squaring block with a 5C collet for a 1 inch. And then so that I can make sure I seat on this for this step of the operation, I've stacked some square and parallel sided blocks here, and I can just push really hard down on this guy and let it clamp on the two sides of this. And we're just going to take some material down here. We're going to be shooting, and we'd like it to be centered, although perfectly centered, not critical. Within a couple thousandths, like 5-10 thousandths would be more than fine. The only thing that's important is the shaft and back relative to this hole here, because that's what it rotates on and that's what it welds on. The rest, it's not a very close fit at all. So we don't have to be super careful, but we'll try and get as accurate as we can, because that's what we do. As an additional sanity check, just run a square off the table up to the part, and it is an amazingly good match. All right, so here we are, and we're working on the second part here. And this one I'm going to be more careful with. Rather than use an end mill, which can suck out of the holder, I could switch to a Welding holder. They tend to be better. My end mills don't have Welding flats on, so they're not exactly ideal for that. It's pushing on this round part, which is not ideal. But instead, what we're going to do is we're going to measure. So as I'm cutting this first side down, last time I was just estimating the depth based on getting a 0 point by just scratching the top. I'm going to take my micrometer and measure over this, and that'll tell me. And then I'm going to use a depth mic to tell in how deep I'm going. Once I get all that dialed in, we should be good to go, and I should just be able to run right in and get this right on the money, unlike last time, which was a pretty big fiasco, if you ask me. Okay, so I cut the first couple bits here, and I'm going to try and get my X depth first, and then I'm going to lock my X axis, and then I'll walk my Z up, because if I ever get a customer that wants this to be precise, I'd be in a lot of trouble, because I was doing a pretty craptastic job. So ultimately, this needs to be 0.708. We are currently 0.344, and I'll verify that. I'll just dial that into my DRO. But let's shoot for 400, and our ultimate depth is going to be 0.708. 5. Might as well see if how close we are. So we're on even value now. That's 0.501. Very close to what I have here. That's a 1/2 thousandth, so we're going to take it. And let's verify we got 0.7. No burrs. We're going to lock off the X-axis now. And now we're just going to increase depth. 50 thousandths passes. I think I should be able to do that. Wow, 2.192. That's right on the money, so we are good. I should be able to flip this part 180 and that Z0 should bring me right back. And I should do a much better job than I did this time than I did last time, which I'm kind of excited about. All right, so we're finished with the first side. That was absolutely a superior method. That let me measure between the bottom, which was uncut, and the top to get my first half. And the second half was just measure over the whole thing. And I'm within 1,000th. And if I was more careful, I could do better. So I'm much happier with this solution. Now, if you had something about the center here very accurately, then I would probably need to put something like a pin in here and measure between the pin and this next section. I need to drill holes all the way through here so I can drill and tap, well, so I can tap both sides to hold the clasps on. So I tap the holes that I drilled all the way through. Here's the piece inserted. This piece fits like so. And then these guys drop down like so. And boy, is that a solid fit. I think we're good. All right, so this next project, fixture, you've seen me make before, but the new variation is how I locate the plates that go on here. You've seen me square this stuff up before. You could use a couple vices, but I find this is the best way. I've got some T-slots permanently, T-nuts permanently in the T-slot in the side here, and I have these plates with adjusters on it using Allen screws, fine pitch, and then a parallel that they push against, and I run an indicator along there to make sure it's square with the x-axis, and then I just push the plate up against it, lock them down, square up one side, flip it 180, square up the other side, and then do the two sides when I move these around. So I might show you a quick abbreviated version of that, but then how I locate where these holes go, or rather what I use in the holes to locate the plate is a little bit different. Something new I ran across on McMaster car, and that's the interesting bit. One more interesting bit is I've got this end mill that exploded. That was an unfortunate bit that you might have seen in an earlier video, but I kept it because it can still do side milling, and that's what I'm going to use it for. So it's not completely dead, and these are rather expensive, so I try and find uses for them if I can, or I try and find alternate uses for them if I can. Cutting the first side, get the best finish with climb milling. Here's a variety of locating studs I found at McMaster car. Here's the screw-in kind. These are kind of neat. They're hardened and hopefully very accurate already, at least the hole through the center, so you can line them up to grind them. And then these guys here are stud-based ones, 1/8 inch and 1/4 inch. This is the 1/8 inch thick, 1/4 inch thick. So I'm going to try the 1/8 inch thick ones first. That way, if I screw up, I could drill a 1/4 inch hole off, offset and still be okay. That would give me just more options. So I'm going to, and besides, these are thick enough already. I don't need a 1/4 inch of material to locate. So we're going to start with these, and we're going to go grind these over on the surface grinder. I've got this rotary grinding fixture. I have a motorized one too. I was going to try the manual one this time, just to get a little better at it. Hold it in a 5C collet, and you rotate this guy once the magnet's on, of course, and it's square. The only downside with all of these things is it's really hard to get in measure because it's facing away from you like this, so I got to come around this side and get the micrometer. The way I set this up is I space it off the back with a bunch of spacers on the bottom, and that helps me get it square, even though that's not ultimately terribly important, but that is how it will go. First I need to dress my wheel, and so I'll take this guy off here, dress this wheel, and then come back and grind these. All right, so this is the last step. I'm going to center drill, and ream this guy. I've got to do both holes on both sides. There's another one over here, one here. And I've got to be very precise about this, so I've double checked measurements. I've run an indicator along the back side here, careful to miss the burr, and I'm within like a few tenths over the whole length, so we should be good. Pushing the holes all the way through. That way I can push this out if I need to, if there's a problem with it. Here's the last fixture plate. I actually have 3 stacked on it right here. These are the 1/8" buttons, so 3 are almost a perfect thickness for it. So I made 0.454, and so there's no slop in this direction, but there is side-to-side slop, which there should be. The fit is pretty darn good. These pieces are mounted underneath here on this side, and that's about it. Hope you found it interesting. Thanks for watching. Hope to see you next time.